Welcome to qnawire.
Hi, so in this case, we're going to have the titration of 50 milliliters of a zero point 0.1 molar solution of HCl. We are going to have the titration using a zero point 0.2 molar solution of sodium hydroxide, and we are asked to get the pH at different points. So first of all, remember that this is going to be a one-to-one relation in our neutralization reaction. Of course, sodium chloride is going to appear as ion into solution, and actually the reactive species are the hydronium ion and the OH that are going to react. So, the different cases for which we need to calculate pH are the following: are the initial, after we have added 10 milliliters of NaOH, when we added 20 milliliters, 25 milliliters, and 30 milliliters of solution. So what I'm going to do is, taking advantage that we have a one-to-one relationship, let's do a table with the amount of mole that we have added at the three different points. So let's say for case 1, we have the volume added. We are going to have the amount of mole of OH minus that we added. We're going to have the initial amount of mole of HCl, which corresponds to the amount of mole of H3O plus. This value is going to stay the same for all of the cases. And then we're going to have the surviving species, the concentration, and the value for pH. So let's begin by 0, 10, 20, 25, and 30 milliliters. So how can I get the amount of mole of OH minus that I have added? Simply I need to multiply the volume in liters. So we can convert all of these to liters simply by multiplying by times 10 to the minus 3. We multiply this by the molarity of my solution, and the molarity of my solution is going to be 0.2 molar. So the amount of mole that we're going to get is 2 times 10 to the minus 3 mole, 4 times 10 to the minus 3 mole, 5 times 10 to the minus 3 mole, and 6 times 10 to the minus 3 mole. We can do the same thing with HCl, but that initial amount is going to be the same always. So N is 50 times 10 to the minus 3 liters, because we have 50 milliliters of solution, times 0.1 molar concentration. So the amount is going to be 5 times 10 to the minus 3 mole. Okay, so I'm going to modify this table a little bit just to make room for some notes. We have the surviving species, amount of mole of the surviving species, which is going to be either HCl or OH minus, and then the concentration of that surviving species. With that, we can calculate the pH. Okay, so let's begin with the very first case. We're going to have volume added 0 liters. The surviving species, it is going to be equal to the hydronium ion that is in our solution. The amount of mole that we have is 5 times 10 to the minus 3 of H2O plus. And the concentration is the same as the concentration of the solution. So the concentration is going to be 0.1 molar. And the pH is directly the minus logarithm of that concentration. So the pH, when we have added nothing, it's going to be equal to 1. for my initial solution. Next up, what I want you to see is that for these two cases, the limiting reagent is going to be OH minus. That means that the species that is going to survive is H3O plus. Over here, we have the equivalence point. So since this is a titration of a strong acid with a strong base at the equivalence point where we have added the same amount of H2O plus to the same amount of OH minus, again, just to emphasize, this number is the same as this number, the pH is the pH of water, because that is the only surviving species. So pH is going to be equal to 7. And after the equivalence point, the surviving species is going to be the excess of OH minus that we have added to the solution. The other information that we need is my initial volume is 50 milliliters or 50 times 10 to the minus 3 liters. Okay. So for the first case, the surviving species is H3O plus. So this number, the amount of mole that we have of HCl, it is going to react with this amount of OH minus, one minus the other, it is going to give us 3 times 10 to the minus 3 mole of H3O plus. In the next case, I'm going to have 5 reacts with 4 of OH minus. We get 1 times 10 to the minus 3 mole of H3O plus. In both of these cases, the total volume is going to be, the concentration corresponds to 3 times 10 to the minus 3 divided by the total volume. So we started with 50, then we added 10, so 60 times 10 to the minus 3 liters. This is mole, this is liters. For the second case, 1 times 10 to the minus 3 divided by 50 plus 20, 70 times 10 to the minus 3 liters. The first one corresponds to a concentration of 0.05 molar. So we can erase this equation. Of course, you can take note of it and get the result. But this concentration is 0.05 molar of H0 plus, so we can calculate directly the pH. And that is going to be 1.3. For the second one, the calculation is going to be that the concentration corresponds to 0.0143 or 1.43 times 10 to the minus 2 molar. And the corresponding pH of that is minus logarithm of that, so 1.845. And finally, after the equivalence point, now the two quantities that we need to subtract is the amount of OH minus the initial amount of H2O plus. So again, we have 1 times 10 to the minus 3 mole, but now of OH minus. So the concentration is going to be 1 times 10 to the minus 3 divided by 50 plus 30. So 80 times 10 to the minus 3 liters of solution. The result from this is 0.0125. Now, how do I calculate the pH of that solution? Well, I can begin with getting the pOH, which is minus logarithm of concentration of OH minus. The result of that would be 1.9. And then get the pH as 14 minus pOH. So 12.1. And that is going to be the final pH for this solution. Let me put it in black just to be consistent with all of it. So, before the equivalence point in the titration, the pH is going to be given by the amount of hydronium ion that I have left in my solution. At the equivalence point, since it is a strong acid with a strong base titration, the pH is given by the pH of water. And after the equivalence point, the pH is given by the excess amount of OH minus that I have added to the solution. And that will be all. Thank you very much.